Hello everyone. I hope you are doing well. My name is Sayam and welcome back to the channel. Right, today we're gonna solve this very interesting problem. And trust me, guys, this is very interesting problem. This problem, like, so I would rate it as medium hard category. Actually, it's a hard problem. It is a hard problem. But अगर तुमने कुछ पहले इस तरीके का प्रॉब्लम सॉल्व कर रही हो, the mixture of two concepts, like just like a JEE advanced problem, multiple mixture, two concepts mix करके एक अच्छा problem इन्होंने frame किया. We'll see the detailed intuition, how we will reach it. We'll see step by step some brute solution, some better solution and optimized solution. स्टेप बाय स्टेप पहुंचेंगे एंड एकदम इंट्यूटिव तरीके से पहुंचेंगे. एंड ट्रस्ट मी गाइस, आफ्टर वाचिंग द कंप्लीट वीडियो विद अंडरस्टैंड एंड बिट्स एंड पीसेस, डोंट जंप टू द ऑप्टिमाइज सॉल्यूशन. Just a small request, because you will understand how we reach it. Now people will comment, oh, how we reach is optimized. Trust the process, go the process, and then you will understand it, right? Let's get started then. Cool. The question is, you're given an integer array nums and an integer k. Perfect. Your task is to partition nums into one or more non-empty contiguous segments such that in each segment the difference between the maximum and the minimum is at most k. What does that mean is, you have to divide your array into multiple segments such that the difference between the maximum and the minimum of each segment must be at most k. Perfect. मतलब उसका जो maximum है, maxi माइनस मिनी, ऑब्वियसली मैक्सी मिनी से बड़ा ही होता है, पर उसको डायरेक्टली मॉड लिखने की जरूरत नहीं है. ये कैसे छोटा होना चाहिए. परफेक्ट. रिटर्न द टोटल नंबर ऑफ वेज टू पार्टीशन इट अंडर दिस कंडीशन. ओके यार, सिंस द आंसर में बी टू लार्ज. ओके, ठीक है. अब जैसे ही तुमने ये रीड किया कि 10 पावर माइनस प्लस 7 से मॉड लेना पड़ेगा, पार्टीशन करना है, you should try to think about, okay, we have two number of ways at partition, means at every index I we have two choices. Either we need to partition or no partition. I hope you're getting it. No partition. Absolutely right. That gives a feel of a recursion, DP, something like that, right? Because we have to try out all the possible ways. We have to try out all the possible ways. But wait a second, let's go to the constraint. And constraint make me sad. Constraints बोलते हैं, constraints हमेशा की तरह धोखा देते हैं. But life में धोखा नहीं मिलना चाहिए, guys. So 10 power 5 or 10 power 4 is the constraints. That means we cannot apply a recursive solution at least. Okay. We cannot apply a n square solution also. But let's try to think about and calmly how can we think about it. If we apply this approach, the partition, not partition approach, can we get something? We won't reach the optimal solution, but at least we can try, because that will make the concept more clear, that how we reach the optimal, right? Okay, so what I told, it's a pick no pick like a problem. It's a partition no partition problem. So you have two choices: either you can partition it or either skip it, right? That is the two choices. But only you can partition only when maxi minus mini is less than equals to k. That is the idea. Skip to you can do always, anytime. That is no condition required, right? Absolutely. So, what we can do is uh, we can partition it every point. So, we will make a dp of I that will tell us the number of ways to partition at given index, at till you can say till ith index. Perfectly fine. Perfectly fine. You can do that. Now, the problem is to maintain this maxi minus mini. People can think, "Ki Sayyam, it is very simple. What you can do, you can make a maxi array. Till ith index, you can get it. A mini array. Till at ith index, what is the minimum value? You can create that. And you can easily compute maxi minus mini. The condition you can check. But wait. Problem is, the problem is, let's say 2, 3, 4, 5, and 6. It's like this. When you try to partition it here, your maxi and mini changes. This is a separate partition, and we are talking about the maxi and mini of a new fresh partition. Now here the mini is not 2. If you do think about this partition, the mini is 4 here and maxi is 5 here if you talk about this partition. That's why that logic of maintaining like a pre-computing a array of maxi and mini won't work. That we got it. Same then also it is very simple. What I will do, key I will write a recursive function with the optimized DP part. What we can do, I can write a int solve function, and what I need to maintain only an index because we need to partition it. Pick or non-pick logic, right? A nums we needed a vector int nums we needed. Otherwise, we don't need anything, right? Okay, also we need, so we can keep the k as well. So we can keep nums and int k also. Absolutely fine. And then what we can do, I'm not writing the other cases. I'm just writing, okay, now what we can do is we have want to maintain this maxi mini logic. Now we, for every j, see, for a given index I, I'm finding the partition index j, whether we can partition it or not. That is the idea, right? We can partition it or not. So what we can do is, what we can do is for every index, what we can do, we can maintain a mini starting with the current thing. We can starting with the current thing, which is nums of I, and same the maxi also equals to nums of I. And what we can do, we can find the j for doing the partitioning thing, for int j equals to I. We can start the partition from the current index also. We can partition it from the current index also because there is a valid, this is a valid partition, right? J less than n because we want larger than that, and we're gonna do j plus plus. And what we're gonna do, we're gonna update these things. Mini will update it, and maxi will update it what with what, mini with minimum of mini comma nums of I, nums of j, sorry. Or similarly maxi with max of maxi of maxi of and nums of j, right? If at any point of time the partition, because we are j, we are going on the right way direction, right? We are going on the right way direction. We are fixing I, we are finding the right index. So what will happen? What will happen? At any point, if maxi minus mini is greater than k, we have to break it out. We have to break because we can't go beyond that. We can't go beyond that. I hope you understand why. Because the partitions, the further partition won't be valid because if एक भी partition invalid हो गया, the whole partition logic is absolutely absurd. Absolutely right. Absolutely right. This is the breaking condition. Otherwise, what we gonna do? This is where we do the partition. So we initialize a ways answer, number of ways to calculate our answer. Let's say 0 here. Then we're gonna sum up over all the possible ways is equals to ways plus solve of. Now, since now our next index become j plus 1 because till j we did a partition j plus 1 and just write everything, whatever is the remaining nums and k, right? This is the answer. And finally, after this for loop, what you can do, you just return the answer. This is all inside the for loop. So you can say that everything what we wrote here, this is inside the for loop, and this is outside the for loop. This is outside. This is the idea. Let's try to think about ki what are the base cases we can think of this recursion. Base cases, Sayam, it is very simple. If we reach till end successfully, if we reach till end, that means this is a valid partition way. This is a valid partition. And what we're gonna do, we're gonna return a one. That means, see, when you are doing a count problem, जब भी तुम count वगैरह की problem solve करते हो ना कि कितने ways हो सकते हैं, and you try out all the possibilities and you sum them up, always go your base cases when you reach the last index, which is the nth index. If I equals to n, you're gonna return 1 because this is a value. अगर तुम पहुंच गए हो वहां तक, that means this, otherwise तुम पहुंचते ही नहीं क्योंकि तुम यहाँ से देखो, यहाँ से तुम क्या किया है, ब्रेक कर दिया है ये वाला लॉजिक से। तो तुम I जो है लास्ट इंडेक्स पे पहुंचते ही नहीं तो काम होता ही नहीं। एब्सोल्युटली राइट। राइट, और ये भी तुमको समझ में आ गया होगा जे प्लस वन, क्योंकि क्योंकि टिल जे तुमने पार्टीशन कर लिया एंड आई से, उसके बाद तुम बाकी जितने ये पार्टीशन है उसको अपन कैलकुलेट कर सकते हैं, एंड वी कैन गोना सम दिस to get our final answer. So what we did nothing. We just from a particular index I, we gonna partition it from I plus one till whatever we want, till j we partition, मतलब कहीं भी कर सकते हो, till n you can partition when there the condition won't break, अपनी condition break नहीं होनी चाहिए तक partition करते जाओ and sum all these ways, sum all, and for each I we are doing that, for each I we are doing, and finally what we are doing for I equals to this is a recursive function, right? This is a recursive function, so what we want the partitions till dp of n minus 1, or you can say directly it will do the recursion stuff also, कि जितने भी अपन को partitions अपन को मिल चुके हैं वो अपन को finally मिल जाएंगे, तो I तक कितना हो गया, n minus 1 तक कितना हो गया, और इसके अंदर उल्टा हो जाता है, तो you can do that dp of 0. This is our recursive state. This is a bottom up approach, or this is our top down approach. This is how we do it, because we pass the zeroth index and then finally it will create our answer. I hope you get it. Ki what we did, we just finally just did it, that okay, अपन एक maxi minimum चला लेते हैं, क्योंकि this is creating for each I. We are finding an optimal j. How many j's we can get it, and for each j we are just summing up the answers, and finally अपन को जो dp of zero वाला जो है वो recursive state है, वहां से अपन को आंसर मिल जाएगा. But the problem is now people will think, same, it is very simple. The time complexity is of n only, right? We just only use one state. Nope, you're absolutely wrong here. See, whenever you calculate the time complexity of a DP solution, you always have to think about the time complexity of the states multiply by the loops used inside the loop. Since this is an n loop, the time complexity becomes n into n, which is n square. That is a problem. And that's why I told people that don't try to rely always on recursive solution. This is a recursive solution. N square, definitely it will work. Let me just quickly show you the code also. That this is the code of the optimized DP part, that what we are doing, we are just finding the long log number of ways. If it is greater than k, we just making it up. Otherwise, we just summing up all the possible ways. For this particular I, we are finding all the particular j's and then finally summing it up, right? And then finally returning the zeroth index answer, because this is a recursive solution, right? This is how we do it, and maximum minimum. But the problem is this loop part. This is not optimized. We are going for every j, and this is compromising our complexity to n square. Can we get rid of this loop? Get rid of this loop. Of this loop. Okay. This is very intuitive to think, at least till now. Now the other part I will tell you. See, the problem in these kind of question happens is now people cannot think beyond this. Why? Because they always know the recursive solution. They don't write iterative solution. Now optimizations can only happen in iterative. We cannot write optimization in this recursive solution. We cannot improve this here itself. We have to write the iterative thing. Now let's try to understand what is happening in the iterative fashion. ठीक है. अब आइटरेटिव अपन समझने की कोशिश करते हैं. अपन ने बोला क्या? अपन ने बोला कि dp ऑफ i प्लस आई लिख लेते हैं, इज द नंबर ऑफ वेज टू पार्टीशन टिल इंडेक्स आई. ठीक है, इस तरीके से वाली अपनी बात हो गई. दिस वी नो दैट. अब इसको कैलकुलेट करने के लिए मुझे तुम ये बताओ कि जैसे लेट्स से मैंने पार्टीशन ले लिया, प्रॉब्लम क्या हो रही है, जैसे 3 4 2 5 7 8 ले लिया, तो इसका इस वाले इंडेक्स के लिए कैलकुलेट कर रहा हूँ. तो मुझे ये बताओ, इसका आंसर किस किस स्टेट्स पे डिपेंड करता है, कि मैंने कहाँ कहाँ पार्टीशन किया था लास्ट टाइम. राइट, राइट, कहाँ कहाँ मैंने पार्टीशन किया था उस पे ये डिपेंड कर रहा है. एब्सोल्युटली राइट. तो कैन यू टेल मी दिस थिंग, कि अगर मैं इसको ऐसे लिख दूं, dp ऑफ i is equals to summation of l till I dp of, let's say you can say k equals to l to I. इसका क्या मतलब हुआ, इसका क्या मतलब हुआ, यू कैन से आई माइनस वन ऑल, बट ओके आई भी कह सकते हैं कि अभी आई तो जीरो ही है। इसका क्या मतलब हुआ, मैं ये बोल रहा हूँ कि अभी तक अपन ने जितना भी अपन ने जे यहाँ तक ढूंढा, यहाँ तक जितने भी अपने वेज पार्टीशन किया, उसके पहले तक अगर अपन ने इसको एक्सटेंड किया इस वाले आई तक, अपन करना क्या चाह रहे हैं, अपन बोल रहे हैं दिस इज द आई, आई वांट टू फाइंड अ एल इंडेक्स, और यू कैन से जे इंडेक्स, यू कैन से जे आल्सो, लेट्स से ये जे इंडेक्स है। अगर मैं इसके पीछे गया, इसके पीछे गया, देन माय दिस कंडीशन विल ब्रेक, मैक्सी माइनस मिनी ग्रेटर देन के, ये वाला कंडीशन ब्रेक हो जाएगा। आई वांट टू फाइंड this optimal j, that this is the last index where this is condition is being satisfied, means our condition would be ये अपनी कंडीशन सेटिस्फाई हो जाए। आई वांट दिस, आई वांट टू एक्सटेंड दिस जे एज लेफ्ट एज पॉसिबल, जितना लेफ्ट में हो जाए उतना पॉसिबल हो, उससे मेरा काम बन जाएगा। देन हाउ इट विल हेल्प अस, इट विल हेल्प अस वेरी इजीली, राइट, बिकॉज आंसर फिर अपन इससे जितने भी प्रीवियस अपन ने कैलकुलेट किए हैं उन सबसे अपन को आंसर मिल सकता है, राइट, बिकॉज यू कैन पार्टीशन इट हियर, देन हियर, देन हियर, बिकॉज जितने भी पार्टीशन अब तक अपन ने किए हैं वो वर्क करेंगे। व्हाई इट विल वर्क, आई होप यू आर गेटिंग इट। It will work because this maxi minus mini condition is being satisfied, condition in being satisfied, and we already know the answer till these indexes. The indexes are like this dp of I is actually is equals to dp of this j till jth index plus dp of j plus 1 plus dp of I. dp of I is still 0, you can say that. So there's nothing. You can take I minus 1 also. That is also fine. That is not a big deal. But the idea is this. How it is help us? Because see that the nums of the I से जो J वाला जो अपना सबैरे है, right? The सबैरे is is satisfying satisfying this maxi minus mini less than equals to k condition. Now, if I push this j at a one step beyond that, like if I do just j minus 1 left one side, it won't satisfy. It won't satisfy. We have to find this j actually. Won't satisfy. That is the idea. Let me just show you with the help of an example also. Let's say this is 3, 4, 5, 4. Right. Let's say our k is equals to maybe 2, let's say, or maybe you can say let 1. Okay. Okay. So we are at this index. Okay, let me just make it 2 also. That will make things more clear. So let's say we are at this index. Okay, fine. We are at this index. Now, what we have to maintain, and we have to see that initially, or we can start also, that will understand you better. Let's say our j's start with 0, because initially our I also start with 0. I also start with 0, right? And we gonna search like this कि कितना last j अपना possible हो सकता है. Fine. This is our answer. So j won't increase because अभी तक अपन ने j ये रख रहे थे. अपन j को move करेंगे rightwards if it is still satisfying, because अपना I तो आगे बढ़ता जा रहा है. I तो every time it will increase. J will increase if it won't satisfy the condition. ठीक है यार, अपन अब इस I पे पहुंचे 2 3, क्या मैक्सी माइनस मिनी सेटिस्फाई हो रहा है? क्या हाँ सेटिस्फाई हो रहा है, कोई दिक्कत वाली बात नहीं है. तो J को अभी भी मैंने 0 पे मेंटेन करा हुआ है. आवर J is maintained here itself. कूल. अभी अपना I इस पे आ गया I. अब देखते हैं क्या अब सेटिस्फाई कर रहा है क्या? नहीं, अब सेटिस्फाई नहीं कर रहा है. That means what I have to move this j, I have to move this j to this position, and I have to check the condition whether it is satisfying. Yes, it is satisfying, so I can compute that. And now from here I know that all the possible answers, it will finally really satisfy the result. The result is maxi minus mini is less than equals to k. That means if we know the j, we just need to calculate this this sum, dp of I equals to dp of j plus dp of j plus 1 till dp of I. Okay, but there is a problem. What is the problem? The problem is if you will iterate on this then it again becomes n square solution. We don't want that. यही तो अपन को चाहिए था कि अपन को ये बार बार समना कैलकुलेट करना पड़े. That's why, see, this is a very 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 standard problem and very important to understand. If you like, this is a actual OA problem, kind of problem. It will happen because this will make the difference. So what you have to do, you have to maintain the prefix sums of the DP, prefix sum of DP. That is the idea. So how you can calculate from the prefix sum is very simple. DP of I equals to what? Prefix of I minus, you can say that prefix of j minus 1. That is the idea. Right? Till j to I अपन को चाहिए, तो अपन इसको I से prefix of I minus prefix of j minus 1, then that will, this is how we calculate the subarray sum, or you can say the sum of a subarray using range sum, right? Using this prefix things. So this is very very important. How we'll calculate the prefix? The prefix is very simple to calculate. Prefix is what? Prefix of I is equals to dp of I plus prefix of I minus 1. Absolutely right. Right. This is how we calculate it. So that is the idea. What, how we optimize this? See, we bypass this loop logic. We are not iterating for all the j's. We are not iterating for all the j's. We're just finding this optimal j, and then we can calculate this sum. Because see, this is contiguous. We can store it in the prefix part, and you can calculate in O of one time. You don't need to iterate. And how can you get this j? This is help of, can be done with the help of a multiset. A multiset. That is the idea. Multiset, right? So what we can do is we can maintain this multiset. How multiset will help us? It will help us to resolve the problem of maxi minus mini condition check. ये कंडीशन भी तो चेक करनी पड़ेगी कि लेस देन इक्वल्स टू के है कि नहीं है. दैट इज इट विल हेल्प अस. तो लेट मी जस्ट क्विकली समराइज दिस प्रॉब्लम फॉर यू इन अ वेरी एंड स्मॉल डिटेल. राइट, देखो, अपन ने स्टार्ट किया एन स्क्वायर प्रॉब्लम से, एन स्क्वायर सोल्यूशन से, कि एन स्क्वायर तक अपन ने समझ लिया था, उस लूप को हमको रेडिकेट करना था. अब हमको ये समझ में आया कि डीपी ऑफ आई का एक्चुअल मतलब क्या है. डीपी ऑफ आई का मतलब है कि टिल ith इंडेक्स हाउ मेनी पार्टीशन आई कैन मेक. राइट, दिस इज द मीनिंग ऑफ डीपी ऑफ आई. आई तक रीच करने के लिए आई कैन कैलकुलेट कि कितने पार्टीशंस में कर सकता हूँ अलग अलग तरीके से. अब इसका आंसर में डिपेंड करता है डीपी ऑफ, लेट्स से कुछ के मान लो, इन के बिलोंग्स टू सम दिस एल, और यू कैन से दिस जे टिल आई. यार कितने पार्टीशन में कर सकता हूँ मैं? आई पे भी एक पार्टीशन कर सकता हूँ, आई माइनस वन पे भी पार्टीशन कर सकता हूँ, आई माइनस टू पे भी पार्टीशन कर सकता हूँ, टिल 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 एक जे पे पार्टीशन कर सकता हूँ. इन सब का वैलिड रहेंगे टिल इट इज वैलिड. मीन्स ना, ये जो अपना जे टू आई सब एरे है, इसमें वो कंडीशन सेटिस्फाई हो रही है. बट द प्रॉब्लम इज हाउ विल फाइंड दिस जे एंड हाउ विल द फाइंड दिस सम. These are the two problems we have to encounter. Now, to maintain this j, we have to use the multi-site thing. The multi-site thing, it will tell us ki, okay, how we can find this j. Initially, we'll make this j equals to 0. And if the condition is not being satisfied, we'll push this j rightwards. It's like a sliding window. Rightwards. It's a variable length sliding window rightwards if condition is not satisfied. Condition, because what we are doing, essentially shrinking the window, condition not satisfied. Right? Absolutely. And सबसे बढ़िया फायदा क्या होगा? वो starting में ही रहे. That would be more larger subarray, more answers, because what we are doing, smaller the j, more the answer of debate, more number of ways to partition it, right? That is the idea. Ab j to I is the last subarray that is satisfying the condition. Otherwise, if we do a slight thing, we cannot add dp of j minus 1 because it is not satisfying till ith index, because ith element we have encountered in our subarray. That is the idea. Okay, or you can say number of partitions. So we cannot include this j minus 1. Okay, yaar. And then to maintain this sum, we use the prefix sum wala logic, right? This is the overall idea. Now the important thing is, for making the things more clear and easy, we have used one base indexing. So instead of representing dp of I with I'm representing with dp of I plus 1 to represent the one base indexing. And similarly for the prefix thing also, I hope you will get it. Okay, let This is our multi-set that we are maintaining for maintaining the minimum minus maximum. And this is our j that, okay, which is the last valid j. Initially, it will start with 0 itself because this is our answer. And let's try to understand. Okay, so we go to 9 and we insert into our set, and then we'll check. Okay, we have to calculate this dp, right? dp will be what? J is still remains 0 itself. There is no change in j. So what we essentially are doing, dp of 1 is equals to prefix of 0 minus 0, because j is still 0. There is no prefix of j minus 1, right? So this dp will update this with 1. What will be the prefix? Prefix is prefix, previous prefix plus current dp. The prefix will become, or prefix will become 2. Absolutely fine. Okay, let's move ahead. Now, if we go to this 4, try to observe this. We insert 4 here. Maximum minus minimum from this set, we can see it is greater than 4. It is 5, right? That means what? We have to increment this j. We have to push our j to the right side. Also, we have to remove this 9 from our multi-set because this is no longer our part, right? So this will be put cell 4 and our j will increment to 1. And then how would we calculate our dp? dp will be prefix of I, which is like 1, right? Prefix of I, because we are standing at what? We are standing it here. So prefix of I, 1, and minus, actually it should be 0. Wait, I am standing at I equals to 1. So I itself, oh sorry, yeah, it should be 1 itself. Already did a 1 base indexing. 1 minus prefix of j minus 1. J is 1, so it would be 0, and 2 minus 1 equals to 1. And does it make sense? It does. Let me just show you also. This will be 1. See, when you are standing at 4 and you have to calculate how many partition you can calculate the partition is like this: 9 and then 4. You cannot do a partition this way. This one, this is not valid. I already explained you, because this is the maximum minus minimum is larger than k. So this is not valid. It's only one partition, and our prefix will become what? 3. This will be 3. Okay, let's move forward. Let's try to move forward. And then we go to our one wala logic. We come here. J is still 1. Try to remember that. Now we'll insert 1 here. Does the mini minus maximum logic satisfy? Yes, it does. There is no need to remove anything. J will remain 1 itself. dp will be what? Prefix of whatever last we have computed minus prefix of 0, because j minus 1 till j it is satisfying. So 2 minus 0, what is 3 minus 0, 1, 2. There it number of ways turns out to be 2. This will be 2. And here if we calculate, it becomes what? 5. So if we got 3, it would be 5, it would be 0. Cool. Let's try to move forward. Let's try to move forward. Now it will be 4 comma 1. This will be already 4 comma 1. Now let's try to move to 3. Okay. Till it is satisfying, minimum is 1, maximum is 4. Till it is satisfying, there is no need to remove from the set, right? Because still our j is satisfying our logic. There's no problem in removing that. Set will help us to calculate the maximum minus minimum. Actually, we are calculating the subarray itself, right? So there's no remove to remove. J still remains 1. And now we will calculate our dp of, you can say, 0, 1, 2, 3, 4 equals to prefix of 3 minus prefix of 0 of 0, which is equals to what? 5 minus this will be 4. Number of ways will be 4, right? We're trying to calculate from the prefix part, right? This will be 4, and this will be what? 9. So this will become 9. 9. Okay. Now what we need to calculate? Let's try to do that. This becomes 4. And last part we need to calculate now, this 7. Now see, 4, 1, also we have to insert 3. I forgot to insert 3 also. So we have 4, 1, 3 until now. And now we have to insert 7 also. So it will become like 7, right? It will become like 7. Now try to understand. See, mini is this, maxi is this. So we have to remove, start removing from the left. We have to increase j. J becomes 2. We have to remove what? J at 4 we have to remove. So firstly we remove 4. See, we have to remove the contiguous order. So 4 we have removed. Okay, no problem. Now what we have to do? Is it still satisfying? No, it's not satisfying. We have to remove 1 also. Right. This we removed. Now our j becomes what? J becomes 2 and then j becomes 3. That is the idea. Now j3 is still satisfying our condition. Means till 3 there's no problem, right? I hope you are getting it. 7 minus 3 is satisfying our logic. So dp of 5, or you can say, yeah, dp of 5 equals to what? Prefix of 4 minus prefix of, now understand that, 2, right? Prefix of 4 minus prefix of 2, because j minus 1 you have to do. This is what? 9 minus, or you can say 3, which is equals to 6 here. You can calculate it, 15, but we just need the 6, and finally the 6 is the answer. So I hope you understood it, how we maintain it, how we removed it, and continuously keep removing it. And yeah, let's move to the code. So yeah. So what I was saying was, see, this is the actual code of implementation. So it's very simple. No, you don't need to do nothing much. It's like maintain a DP vector and a prefix vector. And I already explained you that we have to make a one base indexing, not zero base indexing. Right? It will make the things clear. And I will maintain a set also. Right? We'll insert every element, current element until now what we have inserted. We'll insert it. And then what we'll do. This is very, very important, that we will keep only those elements which will satisfy our constraint. Satisfy our constraint means that the maxi minus mini logic should be less than equals to k. So if our maxi minus mini is greater than k, we'll keep removing the element. What we are doing, we are pushing j towards the right side. Pushing j towards the right side, because we want the minimum j that should satisfy the condition. But if we it is not satisfying, we have to remove it, right? So we are removing it and we're incrementing it to j plus plus. Firstly remove it, then increment the j. Then what we are doing, that's we found out there. Now the j is a valid j. It's a valid j. But before j, till j minus 1, our this is not in our control. Means like it is not in our answer. That means what? We'll calculate dp of I plus 1 from prefix of I minus prefix of j minus 1, because j is valid, j minus 1 is not valid. So till j minus 1 will remove it from prefix of I and will take the mod. And if this is the edge case handling, like if j is itself 0, means we don't need to remove any j. That's why it will directly make prefix of I itself. We don't need to remove anything. Otherwise also, and then how to maintain the prefix part? We just prefix of I plus 1 equals to prefix of I plus dp of I1. The current dp of I1 plus 1 we calculated, and the previous prefix. That is the idea. Very, very important. We are calculating dp of I plus 1 from the previous prefix we have computed until now, minus the j minus 1 part. And don't forget to make the mod here also. Plus mod I am doing. Why I am doing that? Because we're taking a difference. We're taking a difference. And whenever you take a difference, always try to plus a mod and then to a mod, because this is very, very important. Because we are maintaining prefix also in a mod part. It could happen that prefix of I can go less than prefix of j minus 1. You could do the mod constraints. So it's always better to do that. Also maintain the long part, because uh, it can overflow the integer part, right? So this is the entire solution. I hope you loved it. If you have any doubt, do let me know in the comments. I will resolve it. Then see you in the next video. Till then, keep learning. Goodbye.